So let's do this problem. We want to find the minimum value of c equals 5x plus 8y, given that x times y equals 360. We are also going to assume that both x and y are positive numbers. This problem works a little bit differently, although it works in a very similar manner, just the derivative is differently. So this time I'm going to solve for x. So if I solve for x, I have to take 360 and divide it by y. Again, x times y equals 360 is our constraint equation, and then the minimum value of the c is what we're looking for. At this point, I can plug in 360 over y in for my x. Now, I also want to explain that this is not the only way I could have done this problem. If you wanted to have solved for y, you could have done that as well. In other words, if you wanted to divide both sides of this constraint equation by x and then substitute in for y, you would have gotten the exact same answer that I did, just using a slightly different path. At this point, let me rewrite this. The c is equal to 360 times 5 divided by y. I'm going to rewrite that as 1800 y to the negative 1 plus 8y. In order to find a minimum value here, I take a derivative. I'm looking for critical points here. Negative 1800 y to the negative 2 plus 8 is the derivative. I'm going to set that derivative equal to 0. Then I will solve for y. In order to solve for y, I'd subtract 8 from both sides. If you wanted to, you can solve this in a number of different ways. I'm going to multiply both sides by y squared. If I multiply both sides by y squared, I get negative 8y squared on the left-hand side and negative 1800 on the right-hand side. That means when you divide by negative 8, y squared equals 225. In order to find the solution, I take a square root of 225. That means y would be either a positive 15 or y could be a negative 15. I can omit the y equals negative 15 because if you recall, we said we were assuming our numbers were positive. So let me scratch that out. Can't have negative 15 because we're assuming our numbers are positive. Therefore, the value of y is 15. Just so that we're aware that this is a minimum, we can check to see that c was this gives me a minimum by taking the second derivative. Second derivative would have been 3600 y to the negative 3. Notice that when you plug in a 15 here, you get a positive value, which means we're concave up, which means I have a minimum. Concave up means I have a minimum. So I get a minimum value when y is equal to 15, and that would force my x, again, I'm going to go up here, so my x is going to be 360 divided by 15, which is 24. The c was 5x plus 8y. So the minimum value happens when x is 24 and y is 15. That c becomes a 240. So the minimum value is equal to 240, and that happens when y is 15 and when x is 24. Again, I like to use the original c to plug in once I have my x and y. This is how finding minimums and maximums is going to work. We're going to use substitution, and then we're going to use what we know about critical values and their connections with derivatives. Once we've found what value of x and y are going to work, then you can actually find the minimum or the maximum value. So this is optimization in a nutshell.